Okay. So we're going to be in your workbooks, page 109 to start. And what we're going to do today is we're going to talk about how we can tell if something is linear or exponential from the words. And then we're going to look in depth about exponential functions and what they do. So, what is the difference between a linear function and an exponential function? Yeah. So sorry. There you go. Don't follow my brain. So a linear, our rate doesn't change, or the amount doesn't change. So it changes by $2 each month. So I was called flat rate. Constant rate. Consistent rate. And on an exponential, that changes. So it's a changing rate. So if it's changing by like our 3,000, when we did our story yesterday with our job, where we could get a $3,000 rate, that $3,000 was a flat rate of change. It increased by $3,000 each time, no matter how many years it's been. Our percent change, that changed each time, because we got 5%, and then 5% of that, and then 5% of that. And so the amount it changed each time was different. So what we're looking here on page 109 is we're just seeing whether or not they're linear or exponential. So I want you to take like 2 minutes and see if you can, like, work with a neighbor. Totally fine. See if you can tell, are these linear or exponential? Like 2 minutes over. And we'll go through all of them. But I want you to try first. See if we can tell. All right, what do we think about A? Linear. I agree with you. It receives $723 a month. That is a consistent change. So if it is a consistent change or a flat rate or changes by the same amount each time, that makes it linear. How about B? Exponential. It depreciates by 17%. So since it changes by a different amount each year, that makes this exponential. Oh, I love that the numbers don't actually show up on mine. So 9 tenths.
So
How
just
about,
like-
yeah, go ahead.
So just like the per month, we don't look at the per year?
Yeah, it doesn't matter what unit of time it is. It's just whether the rate changes. So this one I would add $723 each month.
Mm-hmm.
So I could add that as many times as I want. I could multiply that by 12 and figure out what I add each year. That's totally fine. This is 17%, and I'd have to calculate that each year at this point to figure out how much it's changing by, because that's going to change. So, C, what do we think? The radioactive substance one. Exponential. Because I have 9/10 of it, which is going to change depending on how much I have. So this one's exponential. How about D? Linear. It's 1 liter, whether that is an Olympic-sized swimming pool or a baby kiddie pool, or it's just a puddle in the bottom of an empty swimming pool, I'm losing 1 liter. So this is linear. How about E? Exponential. Because it's half. It's the half. They threw you off with that 124 minutes. So since it's half, it's exponential. That's actually a special thing called a half-life, which we'll get into briefly a little bit later on. That's more of a chemistry thing, but we touch on it a little bit. Okay, so questions on how we can tell if it's exponential or if it's linear from the words? Okay, we're going to look at the next page as well, which I don't have the number. I'm assuming it's 109 because the last one was 108. I just don't have this yearbook. So it's a page that has a list of equations down it and a whole lot of blank space. 110, thank you. And what we're going to do is we're going to figure out whether these are growth or decay, meaning whether it's growing or whether it's shrinking. We're going to figure out its initial quantity. We're going to find a growth rate. I'm going to describe what the growth factor is, and we're going to get a sketch. So there's a whole lot of pieces on here. And we're going to do it for as many of these as we can. I'm going to recommend that you write at the top of your page, like in that big margin at the top, this formula. Because they don't give it to you, and we will give it to you when it comes time for a test. Like, we'll give you that formula. I believe even on the final we give you that one. I'll double check though. Because that's really going to help us figure out our principal and our rate. Because those are two things that are in that equation. Principal is also our initial quantity. So our initial quantity is P. So it's really easy to spot in these first couple equations because it's the number outside of the parentheses. So our initial amount is what for this one? Our initial quantity. What are we starting with here? 8. Our initial amount is our principal. It's the guy in front. That is not helpful. So it's this piece right here. I'm going to erase this highlight so I can color code things. So my principal is my initial quantity, is my initial amount. R is my rate, which they don't have it listed as a plus or minus here. They've already done that part. So we're looking for our rate. And we're also going to talk about something called the growth factor, our factor here. What our growth factor is going to be the whole piece that has the exponent. So our growth factor on this one is going to be the whole 1.23. So the whole piece that has the exponent is our growth factor. The growth rate is what was added to 1 or subtracted to 1 to make that. So what was there a number added to 1 or subtracted from 1 here? Added. What number was added to 1? 0.23. So our rate is 0.23. Or you can do it as a percent. 23%. Oh, I didn't even talk about, is it growth or decay? So whether we can tell if it's growth or decay is whether or not they added or subtracted. We talked about it, but we didn't give it a name. So was this growth or was this decay? Growth, because they added a number. So when they say sketch, what that means is we're going to give ourselves literally 3 pieces of information here. You're going to give yourself like a coordinate grid. Our initial amount is 8. So on my y-axis, we're at 8. And all we have enough information to do right now is to say this guy is growing. That's our sketch. It curves and it goes through the 8. That's all the information we have right now. And we're going to practice this through a bunch more on this page because I know I kind of went all over the place. Yes, dear?
So the rate is always behind the decimal.
The rate is how 1 was changed. Because that one's a little bit different.
So is it always going to be 1, or can you just say, like, if it's more than 1, then it's a growth, or if it's less?
If it's more than 1, it's growth. If it's less than 1, it's decay. That's another way to think of it. Absolutely valid.
So, since you said if it's 1 when it grows, like the 1.23.
Yep. That's what made us know that it was growth. Because they took our 1.23 and it was, we could rewrite this as 1 plus 0.23. That was the piece that was inside those parentheses. Since it was a plus here, since we added, that's how we knew it was growth. That also tells us that this thing's bigger than 1. So on this one, did they add to the 1 or did they subtract from the 1? Subtracted. So is this one going to be growth or decay? Decay. Okay. What is the initial amount on this one? Our starting amount? 3.1, or our principal. What is our growth factor? 0.78. This one's probably the hardest one on this one. What is our rate? I'm going to say it's what was subtracted from 1. It's 0.22. Or you can put it as 22%. The way you can find that, if you don't spot those easy, because not everybody can spot that easy, is you set it up as a little equation. 1 minus what is 0.78. And you can set it up as a little bitty equation and solve it that way. That is an excellent way if it's not one of those things that's intuitive for you. And for a lot of people, it's not. That's okay. Make it an equation. Do 1 minus r. So we know it was subtraction, so we're going to put subtraction in. What's my rate? And you can solve for it that way. Okay? And then our last piece on this one is our sketch, where we're going to start at 3.1. And we're not doing any kind of scale here, so I know it's on my y-axis somewhere, and I can just label it 3.1. This time it's not growing though. It's gonna get smaller. It's decaying. So it's not gonna go up, it's gonna curve down. And it might go below the line, it might not go below the line, but it's gonna curve down. Questions on these two? We're gonna do a couple more just because some of them get a little weird, and it is weird. The initial quantity, the rate, and growth or decay are things we've talked about before. You do those in Algebra 2 a lot. Growth factor is not a thing that was mentioned before, so that's a whole new phrase. But the last 2 years in the final, it has asked about the growth factor and not about the rate, so that's why I hit factor really hard right here. So we're gonna do another one. So this one is part C, or letter C, whatever. And these ones look like they're trying to trick you. It still uses these. It's still one of, hello laser pointer, there you are. It's still one of these. So if it helps, you can rewrite this, because this is the piece with the exponent. 3 to the t over 2. What is our principal here? What's our initial amount? What's in front of my parentheses? Not 0, because by 1. Because if we multiply by 0, it's just 0, and we've made our whole equation go away. So our principal is here, is 1. What is our factor, our growth factor? 3. So is this growth or decay? It's growth, because my growth factor is bigger than 3, so we know it's growth. Hard one on this one. What's my rate?
220? Or is it 200?
It's 200%. Because it's 1 plus what gives me 3? 1 plus 2 gives me 3. So my rate is 2, or if we put it as a percent, 200%. So we added 2, a whole 2, not 0.2, not 2%, 2. So this thing is getting really big really fast. The thing that this piece is up here, this kind of funky exponent, it's playing with the time. So it's that it's growing by 200% in twice the time. Like it's playing with the time units. So it's still growing by 200%, just in a weird unit of time. And we'll play with weird unit of time later on. So I'm not going to worry too much about that. Just know that it would have to take 2 years for this exponent to be 1. So in 2 years, it grows by 200%. In 4 years, it does that twice, because it plays with that unit of time in there. It's still the same thing when it looks like our sketchy sketch. So our little sketchy sketch, which mine is going to be very tiny because I made some very big choices in my words. It's starting at 1, and it's still growing, so it's still gonna go up. It's gonna triple every 2 units of time. Okay, so it's playing weird games with the time. We're not going to have a ton that use weird units of time. Most of the time, we're going to have things that just use years, because for the most part, we're going to use money. but occasionally they throw a chemistry question at us because they like to do chemistry stuff. And chemistry is half-life stuff until it uses weird units of time. Okay. So there's 2 left on this page. And I want you guys to try them. Try and do them. Try and do D and E. And I believe the 3 we've done plus D and E make up homework number 2. Like that is the second homework. Okay? So we've done more than half of that homework assignment. So I want you to try them. See if we can figure out that growth factor, figure out that rate, figure out that initial amount. What's in front is our initial amount. So our principal is out here. The rate is inside. Our growth factor is the whole chunk that has the exponent. So the factor. Just for our color coding here. Rate. Cool. Oh, and then growth and decay is decided by whether or not it was plus or minus. Okay? So try and do those things. Give them a shot. I try and give you guys time in here to do the homework because I know we're not going to do it if we take it home. Most of us. So try and do that. I've already given you half the answers. So maybe we'll turn it in. That'd be great. Some of us could really use the points.